recording. All right, so as you can see here, you're seeing a beam that is connected with, we have 3 elements here. Okay, we have 3 elements, and then you read the question. The frame consists of 3 elements and subject to a 15 kilonewton horizontal load over here. Apply at the mid length of the element 1. So node 1, 2, 3 is fixed and the dimension is shown in the figure. All right, now this kind of question is very popular when it comes to final exam. So there will be one question from this chapter. So I hope you pay a little bit more attention and ask me question if you're not understand. Okay, all right, the E value is given, A value is given, I value is given. All right, now this is under rigid frame. So each of the point will give you 3 unknown. Okay, so before that, just call back F equal to KD, the general equation. All right, F, K, and D. Now for the D displacement dimension, for each point, we will have 3 unknown, which is U, V, and rotation. Okay, V1, U1, V1, and rotation 1 for D dimension. However, for the force, one point, each point will give you another 3 unknown, which is F1, X, F1Y, and moment at point 1. So this is under F. So this is D. Okay. All right. Sue, are you there?
Yes, sir.
All right. So again, by refreshing what I discussed just now,
Yes.
what do you think? Displacement you have at point 4. Displacement.
Displacement.
What is it? How many?
3.
3.
U4, V4, and rotation 4.
Correct. Okay. So the next question is that you have 1, 2, 3, 4 point. Okay, Ashmal, this one I think you're familiar with the question. I'm asking you about the K matrix, capital K. What is the size of K matrix that you expected in your answer if you have 4 point?
12.
12, huh? Correct. So you have 12 times 12 matrix. It's a very, very big matrix. Okay. So because why? Each point you have 3 unknown. Okay. So you feel U1, V1, rotation 1 until point number 4. So each point have 3, so you have 12. 12 times 12 is very big matrix. Then after that, you use boundary condition, which means you look at point 1, does it can move or not? Point 2 can move or not? Point 3 can move or not? So these 3 points cannot move. So basically, you are reducing 12 times 12 down to 3 times 3 matrix. Okay, I hope you can relate to this one. Brian, you understand, right? How we reduce 12 times 12 to 3 times 3?
Yes, sir.
Okay, good. So this is the general idea before you solve rigid frame kind of question. Okay, so the rest is just mathematics and matrix skill. All right, let's look at the standard procedure. First, we look at the external force here. We need to solve this external force. Yeah, before you solve, you have to pay attention to X and Y. This is global axis. And also in the rigid frame question, you will always see this arrow with the X prime, meaning for element 1, the X positive direction, X prime positive direction is this way. For element 3 is this way. Element 2 is pointing up X direction positive. Okay, Now just a test, Brian, how do you find angle of element 1? Do you know how to find? Based on this diagram, what is the angle of element 1? How do you find? Oh, sorry, element 1. The rest you also try to figure it out. How do you solve angle at 1?
So previously you said that we measure from
where? From
the
how do you
horizontal line.
measure angle? No, how you measure angle? Angle you measure from
X
to
X prime.
X prime. So element 1. So element 1 is here to here. Theta. How you find theta?
Because this diagram,
Yeah,
we can use trigonometry.
correct. So trigonometry, you have 20. You have this height, 40. Okay. So you manage to find by using tangent, find the theta. Okay. And then the other also know, right? For example, element 2, the angle is from here to here. So basically it's 90 degree plus this angle. Okay, 90 degree plus this angle. So you find this angle and then you minus 180 degree, you get theta for number 2. Okay, now it's quite straightforward for element 3. Element 3 straightforward is actually a bonus point. Element 3 theta is 0. Okay, all right. So now we're going to solve this loading. So we're going to convert. Sorry. Okay, we're going to convert this component. You see this 15 kilonewton. We're going to expand this 15 kilonewton into X prime and Y prime direction. Okay, what does it mean? If you look at 15 kilonewton like this, and this is element 1. This is your X direction, X prime direction. You need to chain this horizontal 50 kilonewton into this one. The first one is perpendicular to X prime. Another one is this way. So you have two directions, the purple color, which is this one and this one. Okay, you need to change this 50 kilonewton into X prime direction and Y prime direction. Okay, so these are the first steps. Then after that, you remember after you change, you need to draw something on your answer so that you remind yourself later you're using this diagram instead of the diagram from the question. All right. All right. So then number 2, you will use appendix D. After that, you will use appendix D. After you convert into this diagram, you use appendix D to convert into the equivalent diagram. Okay, so I'm not going to show you appendix D again, but the concept is you change this kind of diagram. So if you see the diagram, this force is actually pressing like that. Okay, so the force you can move, this force you can move either forward or downward, but it must be in the same direction. Okay, this must be the same direction. So if you look at this one and you refer to appendix C, there is one diagram that pointing to the center, and then you can convert this into this diagram with a moment. Okay, then all this value, the force F1y, F2y, M1, M2, you read from appendix T. Okay, you convert this one. So remember, when you convert, you have to carefully rotate your diagram to the diagram. For example, appendix D is pointing down, so this is 0.1, this is 0.2. So when you convert this diagram into appendix D, so this is 0.1, this is 0.2. So don't wrongly label. If you label 1, this is wrong already, because the arrow is pointing down. So you have to like tilt this diagram according to the appendix D. All right, stop me. You're not able to understand what I'm talking about. All right, then after that, this one you convert from appendix D, you get what is the force moment at both ends. Okay, so for example, in this case, you have F equal to B1, M equal to this one. So this one you read from appendix D. Then after that, you combine everything together. Okay, you combine everything together. Right, you draw based on, you need to convert this one equivalent force, you need to convert into global coordinate. Meaning, after you convert this one, you need to change this and this one again back into global dimension. Meaning, this diagram, these forces, you need to expand it back to this one and this one. Okay, back by referring to y and x direction. Okay, I hope you can see from here, right? So after you, it's a lengthy step, but the concept, once you understand, you're able to solve, right? After you convert to appendix D, from appendix D, you need to convert this direction back to global direction. Okay, so from the left diagram into right diagram. Right. Then after that, you run the analysis accordingly. So this is the final adjustment from this one into this one. So this force at the end will become in the direction of y and x. So you can see the force is parallel to the x. All right. Then you practice the equation F equal to F E effective force minus the F0. This is from the appendix D. All right. So the detail you can refer to the previous lecture video or lecture slides. All right. So basically, you take Fe minus the forces you have from the appendix D. Then you combine the matrix. So this is element 1. For example, element 1, the angle, element 1, or maybe I change the color of my pen for more clarity. So this is the angle number 1. So by using Pythagoras or using the tangent trigonometry equation, the angle is 63.43. So for this module, if can, go for 3 decimal place for angle, or maybe 2 is enough, but for the answer, go to 3 decimal place for accuracy. Okay, so 3.43 from x to x prime. Then the first step in the plane frame analysis, you calculate cos, sine. This one you press calculator, you manage to find the value. After you find the cos and sine, you calculate the constant value, 12i divided by L square, you find some value. Then the next one, you find 6i divided by L, you find something. And then EL equal to something. So all these, you substitute all the value and then you find. Because cos, sine, this one, and this one are the constant for the matrix that you're going to substitute inside there. Okay, so this is the matrix that we're looking at. So for element 1, you write K superscript 1 equal to E divided by L times the matrix that you see. So remember, be careful in the test. Normally, we don't give you in the sequence number. So for example, in this case, you see that the numbering is jumping all around. So you have to be sure what is element 1 connected to. So element 1 is 1 to 4. So when you do the labeling or the ticketing number for your matrix, remember to label correctly. So for element 1, you have U1, V1, and rotation 1. And you have the second point of element 1 is number 4. So you label 4, U4, V4, and rotation 4. And then you substitute all the value right in the complete form, meaning after you substitute all the value, you get one complete matrix, including all the number at this form. Okay, all right. So these steps will score you 3 to 4 marks if you get the correct answer. So always check your answer, double check, cross check your answer before you carry forward to the next steps, because you're going to snowball. Even though the negative signs, you check one more time. Okay, most of the time, a mistake I saw in the previous exam is the negative sign. Okay, when you do the symmetry, you forget to carry forward. Sometimes this one negative, but when you pull to the symmetry plane, this one, you accidentally, you'll become positive. So be careful. These are the mistakes that done by student. All right, then the next one, you do the same. Okay, then of course you can close the matrix based on the boundary condition. So for point 1, U1 0, V1 0, rotation 1 0. So you can close the related row and column. You only left out this one. Okay. So for element, this one is the K element 1. Okay, that you need to do when you do the superimpose later on. All right. So element 3, again, you find what is the cos, what is the sine. You see, the procedure always the same. You find cos, sine, then you find the constant value, 12i divided by L, 6i divided by L, and then the EI divided by L. Now, one of the area, normally you need to check your unit. For example, area and I. Make sure they are in meter square for area and meter power 4. So if the exam purposely trick you for mistakes, normally we will use power 4 in this area to trick you. So to see whether you're aware or not. So if you do not change 4 to meter power 4, then it will snowball to all your answer. Okay, so this is one of the famous trick by the lecturer. Okay, normally we'll just change one of the unit in a question, and if the student didn't aware, he straight away use the value. Then we don't need to mark the question already, because the substitution will be wrong. Okay, just be aware on the unit. All right. Then after that, you do the same. You substitute all the value, and for element 3 is connecting 4 and 3. So you can see you label number 4 and then followed by number 3. Okay, so U4, V4, rotation 4, U3, V3, rotation 3. Okay, according to the diagram here. Then you do for, okay, then you close also for boundary condition. You only left out this section. So for element 3, you only need to concentrate on this point. Then for element 2 Element 2, the angle you need to find. I already explained how to find the angle just now. So element 2, you have to see how do we know the number that we should write in the matrix by following the arrow given in the diagram. So for example, you look at element 2, the x prime arrow is pointing from 0.2 to 0.4. So when you write your matrix, you start with 0.2, then 0.4, meaning you start with U2, V2, rotation 2, then only followed by 4. Same with element 3. You look at the x prime arrow. So that's why just now we start with 0.4 and then 0.3. Then for element 1, also we start with 1 to 4. So be careful. This arrow is important to guide you how to do the matrix ticketing method, right? So be careful, pay attention on the arrow. So once you find the angle, same steps, you find the cos and sine, and then find the three constant value, 12IL square, 6IL, and the EL. Then you put into this matrix, okay? Then you do the superimpose. All right. Now, just want to remind you that when you do the superimpose, you have to be careful, especially the value of EL is different. Okay. All right. Now, what does that mean? It means that, let's say, for K element 1 equal to 10 power 4, and then sum of the matrix here. Then K number 2, maybe you only get 10 power 3. Then K number 3, you get 10 power 3 also. You need to, before you do the superimpose into capital K, make sure you change the constant value the same before you superimpose. Okay, because the outcome of K later on, you must have the same constant value outside. In this case, I choose 10 power 3, and then you do the superimpose. So to reach 10 power 3 at the same stage, you need to convert the first one. Okay, you need to convert the first one, this one, into 10 power 3 by 10. And then let's say you have 3 number here. Okay. So this 10 power 4 will become this new matrix here. Will become 10x, 10x, 10x. All this you have to time 10s. 10x, 10x, 10x. Okay, apologize for my writing, but you will get the idea. Okay, so you need to use this new form to do the superimpose. So this one will combine with this one and this one to get this one. Okay, so be careful. This is a very important steps. Usually this is also one of the area where students make mistakes, careless mistakes. Okay, it's more on mathematics careless mistakes. Okay, just take note on this one. All right, so once you combine, you will get F equal to KD. All right, so you will get F for X, F for Y, M4, because you know that your D that you are calculating is only point number 4, because point 1, 2, 3 cannot move. So you're only considering point 4, U4, V4, rotation 4. So point 4 at the force component, you only have force in X direction, force in Y direction, and also moment. Then the K metric is the superimposed just now. Right, so from there, you know, then you there, okay, then you solve lah. You solve for this 3 equation. right? Solve for these three equations, then you manage to find what is the value for these three. Okay. All right. Then after that, you go for element force. You use this equation, F prime equal to K prime T and D. So recall what is T. This is standard. You copy this one in your answer, you get 1 to 2 marks. You copy this one, all right. Then you substitute because TD, you are referring to element itself because this is a prime. Prime is referring to element. All right. So this one this is more detail on how you calculate. All right. But basically, when you substitute all this number inside there, because you already have the cos and sine for that particular element, then you use the online matrix tools that I teach you before. You just need to key in the value for the T, the value for D. Then you do the multiplication, and then you key in the value for K prime. You do the triple multiplication in the calculator. You manage to find the forces for the element. Okay, so this is just a detailed steps for you to refer to. Okay, all right. So this is for the effective nodal force Fe that you change into x prime and y prime axis cases. All right. So this is how you solve it. Right. So I label all these in solving the question. Then after that, you take the Fe minus the one that you refer to appendix D. Then you get the final forces inside the element. Okay. So for example, I'm showing you the example answer. So you take the Fe, Fo, you minus, you'll get the one on the right hand side. Okay. Then you fill in the forces. Okay, you fill in the forces because you have the forces, you have the moment, you have for each point you have x direction, y direction, and moment. Okay. Same with number 4 here. Right, so practice this one. Practice for element 2 and 3, the same way, you get the similar pattern, right? So these just guidelines for you. Okay, then the rest of the tutorial question, I expect you go and read. So the steps still the same. So you go ahead and view all the PowerPoint slides, just as your home revision, right? So the steps still the same. I don't think I need to go through all this. Okay, so again, there will be one question coming out, and your assignment 2 is from this chapter. Okay, I end this recording.